this video, I want us to review the material in Chapter 4 on factorial analysis of variance. This will give you an opportunity to review the material that you've read and hopefully to begin to hear it in a way that will bring it together for you. We work through this. We want to begin by looking at our review of ANOVA. And for a full review, you can look at your textbook from 9615 and look at Chapter 15, where you will see ANOVA discussed. But the key aspects of ANOVA is that you have one independent variable. And that's very important for us to understand that there's one independent variable. And the independent variable is that variable which does not change. Now understand that what we're talking about with the univariate, that you only have one independent variable. However, there are going to be more than two divisions within that independent variable. So let's use an instance like a university status. So you can have freshmen, sophomore, juniors, and seniors. And the independent variable is your year of college. And that's the independent variable. There are four groups within that independent variable, but the overarching variable is year in college. Now with ANOVA then, you have two or more groups that have a score on some instrument. So we've got our univariate variable, which is year in college, and their score is going to be contentment with life score. And that's going to be a scale score that each one of those groups will have a mean that we will work with. But there's only one independent variable and two or more groups within that independent variable, and each of those groups have a score or a dependent variable, the treatment condition. Now the independent variable is known, when we're talking about these ideas, it's called a factor. So with the ANOVA, we only have one factor. For the ANOVA, you compute the F ratio, and basically this is what you're doing. You take the variance between the participants, that is, the difference in their treatment scores, and the variance due to chance, which is an estimated idea that we come up with, and you divide those by the variance due to chance. So we're in a sense taking the variance due to chance out of it, and what we come up with then is the variance between the participants. Now the null is stating that this ratio is 1 because 0, there is no difference in the participants' scores, so therefore the variance is 0, and the variance due to chance is what we've estimated, and we divide that by the variance due to chance, and so that will give us a ratio of 1. And so the F ratio then shows how far away from 1 that variance between the participants has made in the difference, and that gives us the F ratio, and there we go. So the closer the F ratio is to 1, you do not have a significant difference because the variation is only due to chance. So further away from 1 you get, the more opportunity you have for a score that becomes significantly different. Now in factorial analysis of variance, remember that a factor has to do with the independent variable. Here we have a bivariate where we have at least two independent variables. So let's go back to our discussion of our first variable is going to be year in school, year in college, freshman, sophomore, junior, senior. But now we're also going to add another variable, and we're going to add gender. And here we have male and female. And so we have two or more groups. So we have our two groups with the 4 levels of college, and we have another dependent variable where we're going to add male and female, our gender. And then we're going to have a treatment condition or a score for each. And again, our score can be contentment with college life. But now we're going to see if there's a difference between contentment of college life according to your level in school, according to your gender, and according to how your gender and level of school interact. And so the IVs are factors. So the difference between ANOVA and factorial analysis of variance is we're analyzing multiple factors. And when there are just two independent variables, as in our example, the process is called a two-way analysis of variance, and the measures are independent. and we will look at one of the ideas that we have there. You might think, well, why don't we just do t-tests between these ideas? And we could do 3 t-tests. We could take the independent variable 1, which is you're in school, and its effect on your college contentment score. Then we could take your gender and its effect on your college contentment score. And then we could see what the interaction is between your gender and you're in college on your contentment score. But this would introduce error because you're doing all of these different procedures independently of one another, and the tendency to get error and provide an unreliable result comes up. So the effects of each of the IV on the DV, the independent variables on the DV variable, are called main effects. So we're going to be testing the main effects, and then the process first computes an ANOVA for each of the independent variables and the dependent variable, and then computes the interaction between the independent variables as a variance not explained by the main effects. An additional ratio formula is then used. So we go back to our formula that we used with ANOVA, but now it's a unique one for the. So we have the variance not explained by main effects, and that is the interaction between the, in this case, the 2 independent variables, and that's then divided by the variance due to chance, and that gives you your answers for your factorial analysis of variance. Now, using the line plots, we view the interaction of the independent variables, and you can see the example on page 77 in the text. And there are 3 types of plots that we can find. There's no interaction where the plot lines are parallel. There's ordinal interaction where the plot lines are not parallel, but they do not cross. And then we have disordinal interaction where the plot lines are not parallel and they do not cross. When you look at our example that we worked through in the textbook, you will find that we have a disordinal interaction, but this is not going to be fatal for the factorial analysis of variance. Now, what are some of the assumptions and limitations that we have to keep in mind as we look at the data and how we collect that data for doing a factorial analysis of variance? First of all, the individuals in the sample were randomly selected or independent. So again, our selection, how did we choose them? And that's why randomness is so important in our selection of our sample. Now, are they normally distributed? Does that mean that the variances that you're looking at are distributed normally across the population? Now, the factorial analysis of variance is not sensitive. However, you want to check with histograms and box plots and review skewness and kurtosis and goodness of fit. You want to get your data to be as normally distributed as possible, and that's where you check these ideas as we go through checking normality, and that may be where we transform the data to get it more in a normal distribution. The other assumption then is the equal variability. There's a homogeneity, and this is very crucial, and we're going to look at that as we solve these ideas, and homogeneity is very important. Now, to test homogeneity, there are 3 options if the sample size is equal, and that's Hartley's, Cochran's, and Levine's. And there's one option if the sample size is unequal. One is much, much larger than the other. For most of our examples, we're going to be using the Levine's test as we're looking at, and we want that Levine's test to not be significant. If the Levine's test is significant, that means that we don't have homogeneity, and we'll have to look through our data at that point. Interpreting the results, we get an F ratio, and we're going to look at significance and confidence levels, and we're going to look at F ratio for each factor. That would be the F ratio of the first independent variable, the F ratio of the second independent variable, and then the F ratio of the interaction between those variables. For the F ratio, there will be 2 degrees of freedom for each of those 3 areas that we look into. And we're going to discuss this further as we look at the chapter sample.